This is my sequence here. First off, we shall go to the HMI. You can see virtual cylinders A and cylinder B all set up ready to indicate the show. We have a reset for the counter. We have our start, stop, resume. We have a number of cycles we can set. We can set this to 3, 2, 1, whatever we'd like. Predominantly we'd want 2, but for testing purposes we'll show that that the value we want is 64 to show for further issues in this code. We'll start, and you'll see that the sequence will start. We've restricted the flow, so it starts for testing purposes to find if there was any hardware malfunctions, the sensors possibly. We've also done this to check when the signals are firing, and it's easier to debug the code because there's issues. I can stop the code at any time before continuing on, or I can pause. So this will wait for 5 seconds before continuing. I could resume if I want to. Back here we have a green light here, which will say that the second sequence in the code has been completed, which is the V+ sequence with the red indicator here. This shows that the count trigger isn't going on, even though it is. This may be because the signal is coming at such a higher frequency that the lag of the HMI can't keep up with it, and it can't be physically displayed. We found a glitch with cylinder A where it would fire very rapidly, very quickly with signals, but would just move forward and back a little bit. Between cylinder B, this might be a malfunction that was a one-off with a physical switch in cylinder B. So we found this is just one temporary glitch that happened. In the code, as you can see here, we only went through the sequence twice, and very quickly the value of the counter hit 64. This is because of multiple signals that I assume will rapidly trigger the counter. This is this activate counter here. As it's being triggered, there's multiple values being sent, and then very quickly it accumulates very, very high onto the code. We tried a new counter. This is a counter up and down. This is to prove that the counter isn't an issue and it's not just a separate function part of the code which is having a malfunction. And we've also moved around the resets in the code so that the resets here that are in the sequences are off at different rungs because of ladder logic, and this is to make sure that there isn't a problem with the code in respect to the reset and the set being on the same line. Find that most likely there is a shortcut or loophole in the code where the signal is able to bypass certain parts of the code and rapidly activate the activate counter tag, which is creating a very high amount of counts in the counter. Through a lot of testing and debugging, this is the most likely issue, and we've found that other ones disproved other types of possible malfunctions or issues with the code.